Hello everyone, it's Mr. Kablan here, and today I'll be starting off the first lesson in the brand new chapter for chapter 7, and it will deal with the topic of quadratics. In fact, this chapter as well as the next will be dealing with that particular topic, and today we'll be looking at multiplying two binomials. Now, before we do that, I just want to quickly go over something that we've done in a previous chapter and something that you were introduced to back in an earlier grade over here. So I just want to quickly review that so you can have a nice idea what we're going to be dealing with in today's lesson. So back in grade 9, you learned what was called the distributive property, which we also reviewed in chapter 4 here. And let's just use an example of, let's say, 2 and in brackets x plus 4. So remember that when you have a number inside of a set of brackets over here, what you can do here is to perform the distributive property, where you need to distribute the 2 to the x, okay, and the 2 to the 4. Now remember that when you distribute a number to terms inside of a bracket, what you're really doing there is multiplication. So when I multiply the 2 to the x, okay, that's going to give me 2x. Okay, and then when I multiply the 2 to the 4, that's going to give me 8. Now, the reason why I'm reviewing this particular topic here, because we will be using something like it in today's lesson. The only difference is that it's going to look different. It's going to be a brand new concept that we will be dealing with for this chapter here. So let's get right to it here, and let's talk about what it means to multiply two binomials. So when we're multiplying two binomials, what you're going to see in every question is you're going to see two sets of brackets. And what we want to do with the two sets of brackets is to expand it and get something in, an expression in the form of ax squared plus bx plus c. Now, just to recap from chapter 6, remember that anytime you see an expression where the letter x has an exponent of 2, that tells us there that what we have there is a quadratic relation. And what we want to do for today, again, is to go through the steps that we need to do to start off with two brackets, okay, and then wind up with something that has 2 or 3 terms here. Now, the technique that I'm going to introduce to you is quite easy to remember because it's a word. There's an acronym and it's a word, and that acronym is FOIL. And what that involves is what's called first, outside, inside, last. Now, what I like to do when I present this lesson, I like to use a lot of colors and arrows here. So what I want you to see in each example is that the steps are exactly the same in terms of what we need to do anytime we multiply two sets of binomials. Now, you know, I've said this several times already over here. I've mentioned the word multiplication. So every time that we are multiplying variables or numbers together, that's indeed exactly what we're doing. All right, so let's take a look at some basic examples first. So if you take a look at the two examples I have on the screen so far, okay, both of them have two sets of brackets, and you notice that both of them have the letter X in each bracket there. Now, just like we did in the previous slide there with the distributive property, we're exactly going to do that for these two examples with one slight twist to it. Now, remember just a few seconds ago, I introduced you to an acronym called FOIL, which stands for first, outside, inside, last. So each of the questions that we'll be dealing with today will involve those 4 different steps. So let's start off with first and outside. Now, what that refers to is that you're going to take the first term in the first bracket, and then you're going to distribute it to the 2 terms in the other bracket. So this x over here is going to multiply itself to the x in the other bracket, as well as the 5 in the bracket like this. Now you notice I put this down with arrows just to show you exactly what you are multiplying. Now here's a part that's also relatively new for you. When you multiply 2 of the same letter together, and you notice I'm multiplying 2 x's, you then get x squared. So just remember that when you multiply 2 x's together, it's always going to give you the x squared. Now, just from a previous chapter as well as in previous courses, when you multiply a number to a letter, you're just going to glue the 2 together, and then you're going to write it down with the number in front of the letter. So when I multiply the x to x, as I said before, you're going to get x squared, and then x times 5 is going to give me 5x. So those are our first two terms. So this is what's called first, because you're multiplying the first term in the first bracket to the first term in the second bracket. And it's outside, just as a reminder that you're going to take this first term and then multiply it to the second term in the second bracket. So those are the first two steps. Now, the next two steps here are inside and last. So what that deals with here is you're now going to take this 2 from the first bracket and you're multiplying it to the x and to the 5. So remember that when you multiply a number to a letter, just grouping them together. So 2 times x is 2x, and then 2 times 5 is 10. All right, so that's basically what you need to do to multiply two binomials. So for the final step, you just need to gather the like terms here. And for simplicity in this course here, that you're just going to take a look at the two terms in the middle and group them together. So when you add the 5x and the 2x together, that's going to give me 7x. So the final answer here will be x squared plus 7x plus 10. So you notice how we start off with two brackets, okay? And our final answer wound up with three different terms: an x squared term, a term with an x, and a number on its own. All right, so that's an example of how we can take two binomials, okay, and then wind up with an answer with three different terms. Now, before I look at the next example here, when we're dealing with this topic as a whole in this chapter, I call this the forward procedure. And the reason for that is because what we're doing here is we're multiplying to get something in the end here. In the next couple of lessons in the remainder of this chapter, we're actually going to work backwards, where you're going to start off with something like this, okay? And then you're going to learn the techniques in terms of how you can take this and wind up with that, okay? But we'll worry about that in a future lesson. Just going to give you a heads up. All right, moving along. Now, when you are multiplying letters and negative numbers, the rules of integers do apply. So for this next one, we need to be a little bit careful when we're distributing our terms to into the other bracket here. So when I take this x and multiply to this x, just like the previous question, that's going to give me x squared. And then x times 4 is going to give me 4x. All right, so that part, not too different from what we did in the previous example over here. Now, this next one, you need to be careful. What we're doing next here is we're multiplying the negative 1 to the x, okay, and the negative 1 to the 4. So when I multiply the negative 1 to the x, that will give me negative 1x. And remember, when you multiply a negative to a positive, you're going to get a negative number. So when I multiply the negative 1 to the 4, that's going to give me negative 4. All right. Now, just to double check over here, if you take a look at these two questions so far, notice they're very, very identical in terms of what the in-between steps are. So for the final step, just like the previous one, we're going to group the two middle terms. So 4x minus 1x is going to give me 3x, which is going to give me x squared plus 3x minus 4. So again, when you're looking at multiplying two binomials, okay, you're actually doing 4 different steps of multiplication, and the final step is just grouping the middle terms together, okay, either by adding or subtracting, depending on what the signs are. All right, let's move forward here, and let's look at another example. Now, for this one over here, again, the only difference between this question here and the other ones before is that both the brackets happen to have negative numbers. So again, we just have to be a little bit careful with this. All right, so in this case here, we're going to multiply the two x's together, which gives us x squared. And then x times negative 6 is going to give us negative 6x. Now, for this one over here, this time we're multiplying negative 3 to the x and the negative 3 to the negative 6. Now, negative 3 times x is going to give us negative 3x. But remember, when you multiply a negative to a negative, that's going to give you a positive. So when we multiply this negative 3 to the two terms in the other bracket, it's going to give us negative 3x plus 18. All right. And last but not least here, gather the two middle terms. Now for this one over here, just make sure that you're including the negatives that are in front of the numbers here. So we're going to take the negative 6x and subtract 3x from it, which is going to give us negative 9x. So the final answer for this will be x squared minus 9x plus 18. All right. So those are the basics of multiplying two binomials together. And you notice that all of them had something in common. Notice that all of our final answers have wound up with 3 different terms. Again, an x squared term, a term with an x, and a number on its own. All right, so the next set of examples now, we're now going to see what happens when we have two brackets with two letters and the letters happen to have numbers attached to it. Now, before we proceed here, keep in mind that when you are performing and multiplying the two binomials, the basic rules of multiplication do apply, and you're going to see that once we have numbers, as you can see in the two examples I have so far on the screen. So what we're going to do for this one over here, exactly the same thing. So we're going to multiply the two letters together and factor in that the x in the second bracket happens to have a number 2 in front. Okay, so we're going to take this first x, multiply it to the 2x. Okay, so that's the first part. And the outside part is when you multiply the x to the 3. All right. Now, as I said before, the only difference with this question here is that when we multiply this x, we're multiplying it to the 2x. Now, from the previous examples, remember when you multiply the two x's together, okay, you wind up getting x squared. The only difference with this one here is that we're multiplying this x here to this 2x, so that's going to give us 2x squared. So when we multiply that x out, we get 2x squared plus 3x. All right, so that's the difference with that one. All right, this next one here, we're now going to multiply the 4 to the 2x, okay, and the 4 to the 3. Now, when I multiply this 4 to this 2x, okay, what you're doing here is you're multiplying the 4 to the 2, okay, and the x happens to be attached to it. So 4 times 2x will give me 8x, and then 4 times 3 is going to give me 12. All right, so the only difference in this case, believe it or not, is just the multiplying of the numbers in front, but everything else is pretty much the same. So last but not least here, the two middle terms, group the two middle terms together. So 3x plus 8x is 11x. So the grand finale here is 2x squared plus 11x plus 12. All right, so if you take a look at B here, okay, you can pause the video for a moment, and I want you to try this one out, okay? And again, please make sure you're careful with the signs. All right, so for this one here, we're going to take the 3x and multiply it to the x, okay? And we're going to take this 3x and multiply it to the -1. Okay, so just be careful when you do that for this step over here. Now, 3x times x, remember that anytime you multiply two of the same letters together, it becomes x squared. The only difference with this one here, this happens to have a 3 attached in front to it. So 3x times x is 3x squared, and then 3x times -1 will give me -3x there. All right. Okay, and the next part, we're going to multiply the 2 to the x and the 2 to the -1. So we've seen this before. So that will give me 2x and -2. Okay, and last but not least here, we're going to group the two middle terms together. So don't forget you're taking -3 and you're adding 2. So the final answer for this will be 3x squared minus 1x minus 2. All right, so now you've seen two examples dealing with two binomials where the letters have numbers in front. So let's take a look at one more. So for this one here, I just want you to see that we are indeed still multiplying. And in this case here, I'm just giving you an example of what happens when you have both x's in both brackets that have to have numbers in front. So keep in mind that what we're doing here is multiplication. So when I multiply this 4x is 5x, okay, you have to also you have to keep in mind that you have to multiply the 4 and the 5. Okay, and the x times x, that's going to give me x squared. All right, so that's the only difference with this question here. And I'm going to take this 4x and then multiply it to the -2. So 4x times 5x, okay, is going to give me 20x squared. And then 4x times -2 is going to give me -8x. Okay, so let's be careful with the first one there, because remember that you are multiplying the numbers that are in front of the x's here. All right. Okay, and this one here, we're going to take the 1, multiply it to the 5x, and the 1 multiply it to the -2. So this is going to give us plus 5x minus 2. All right, and as we've done in every example so far, the two middle terms, you're going to group them together. So -8x plus 5x is going to give us -3x. So the final answer for this will be 20x squared minus 3x minus 2. Okay, so now that we've seen two different types of examples of multiplying two binomials over here. So for the next one over here, okay, we're going to look at a special case where we actually have to do one additional step, okay, before we do all of this over here. So if you take a look at the examples that we have here, okay, notice that in these examples, we only have one bracket. Okay, just as a reminder, all the examples we've seen before have had two brackets. So this one here has one additional step that you need to remember. All right, so in these ones over here, the first thing you need to do, okay, is you need to take what's inside the brackets, okay, and write it down twice. So that's our very first step. Now, notice that once you have it with the two brackets, then you, once again, you just perform FOIL like we did in the first set of examples here. So you're going to take the x and multiply to the x, so that will be the first. And you're going to take the x and multiply to the -7, which is the outside there. So we have x times x and then x times -7. So x times x will give me x squared, and then x times -7, that's going to give me -7x. Okay, and just be careful with this next one over here because we have a -7. So we're multiplying -7 to the x, okay, and then -7 to the -7. Now, just as a reminder, when you multiply two negative numbers together, that you get a positive number at the end there. So we get -7x plus 49. Okay, and the two middle terms, we're just going to group them together. And this, the final answer for this will be x squared minus 14x plus 49. All right, and this next one over here, again, exact same step. Take what's inside the brackets, write it down twice. Okay, and I just made a little tiny note there that this is what's called a perfect square trinomial. Okay, that's just some additional piece of information there. Now, for this one over here, again, exactly the same thing. The only difference I just want you to pay close attention to is that there is a number 3 in front of the x here. So when we multiply the 3x, don't forget you're multiplying it to the 3x in the other bracket. And you're going to take this 3x and then multiply it to the 1. So 3x times 3x is going to give me 9x squared. And then 3x times 1 is going to give me 3x. All right, and just to finish this off here, we're going to take the 1 and multiply to the 3x, and then 1 and multiply to the 1. Okay, and that's going to now give us 3x plus 1. And last but not least, again, you should know, but you should see it's exactly the same thing that we've been doing. Take the two middle terms, which are the like terms, add them together in this case. So our final answer here will be 9x squared plus 6x plus 1. All right, so just remember when you're multiplying two binomials, notice that every question we started off with has had two sets of brackets. The only difference with these examples here is that when you see only one bracket and you have an exponent on the outside, don't forget to write it down twice, okay? Then you perform FOIL from there. All right, so let's take a look at a quick word problem here, and it deals with the area of a rectangle. And it tells us here that a rectangular ski area has a width equal to x plus 3 and a length equal to x plus 5. And both are measured in kilometers here. Okay, so just to do a quick diagram over here, we have a width of x plus 3 and a length of x plus 5. Okay, and when we take this, we're going to use a formula that you probably are familiar with from grade 9, which is length times width. Now, all we're going to do with this one over here is set it up using two brackets, just to show you again that we can use basic formulas to just FOIL, and you can see the relationship between the two. So you can see the length here is the x plus 5, and the width here is x plus 3. So all I'm going to do is I'm going to replace that in the formula for area, and it's going to look something like this. Okay, now it looks really familiar to you now, doesn't it? All right, now we have two brackets, so let's perform FOIL over here. So let's start off with x times x, which is x squared, and then x times 3, which is 3x, right? And then we have 5, we have the 5 here multiplied to the x, and then 5 and multiplied to the 3. And that's going to give me 5x plus 15. All right, and group the two middle terms together, and that's going to give us x squared plus 8x plus 15. All right, so notice there's nothing really new in this particular question. The only difference is it's a word problem where we had to use a formula first, okay, and then replace the, in this case here, the length and the width with the two brackets there. That's pretty much it there. All right. Okay, so it says using your expression from A, which is this part over here, it says find the actual area when x is equal to 3. So step number 1 here, write down what we have from the previous example. And all we're going to do here, and if you have a scientific calculator, you might want to try this out because we can actually do this in one step here. So all we're going to do is x equals 3 is we're going to substitute it in for each x. And remember that anytime you substitute a number in for a letter, you always put brackets around it like this. All right. Now, if you carefully put this in your calculator, okay, you put the 3 in brackets and you square it, okay, and you go plus 8 in brackets 3, and then plus 15, okay, that should give you a final answer there of 48. Now, if you don't have a scientific calculator, okay, I just broke it down for you in the previous step here. So 3 squared gives me 9, okay, 8 times 3 gives me 24, and then we have the 15. We add them together, and we get 48 square kilometers there. All right? Okay, so that pretty much wraps up this lesson here. So as you proceed here, you can start working on the questions in the textbook, or you can start working on the questions in the review, section 7.1, which is in lieu of the questions from the textbook, give you some nice practice there. So until next time, I'll see you then.